So our presenters today, we have Jason Bramer, variation analyst and our CATIA specialist. Jason's been with DCS for 5 years, been working CATIA for almost twice that long. However, in the last year, Jason has been working quite a bit in NX as well. So Jason is very knowledgeable in both CATIA and NX and in 3DCS applications, and he will be our main presenter today. Now, Brenda, unfortunately, is out sick, so I have Dave Johnson, the 3DCS product manager, here to join us to help with question and answer and to assist Jason with any topics that he might have some additional feedback on. Today's software. So today we will be showing the features and tips in 3DCS Variation Analyst CAA V5 based, which essentially is our CATIA V5 integrated version of 3DCS. However, I do want to point out that all of today's features are available in all versions of our 3DCS suite, whether you have the standalone version, 3DCS Multicad, whether you have the NX integrated version, the 3D Experience, which, CATIA V6, or if you're using our CATIA V5 integrated. So regardless of what version of 3DCS you're using, all of these are applicable to you. For simplicity's sake, we're going to be using just one system rather than switching back and forth between them today. The agenda, we're going to be starting with feature points. So throughout you can see by today's agenda, we're going to be starting from basic points, moving through GD&T into joints and constraints, which in 3DCS are moves, then talking about creating measurements, and then how to copy data so that you can quickly create more tolerances, moves, and other features on your model quickly. So we're trying to showcase how to build a model based on your CAD data that's already available to you. All right, at this time, I'm going to be passing presenter over to Jason. All right, Jason, if you want to say hello.
Good morning, good afternoon, good evening. I'm going to share my screen. This thing out of the way. And I'm going to first suggest that if everybody has availability to access our community, I did make a post on this already yesterday, just called 3DCS Modeling Best Practices Part 2. And so we have our topics within there. So if you want to answer questions, you can ask them in there, or ask questions, you can ask them in there, or you can make a new post and or search within the community for any other stuff that we cover.
So just to reiterate on that, the DCS community, I'm putting the link into the chat. The DCS community has forums, webinars, articles, our DE Focus articles, the help files, and is freely accessible to all of our users. So if you go to the community, you can register and get instant access to all this information. We can ask questions. You can search based on your questions. So if you're working in 3DCS, you've got some quick questions that come up, the community is a great resource for you to use. So we just highly recommend that as a follow-up to this event.
Okay, so starting off with what Ben said, we're going to start off with just using really basic feature points. And to go into it a little bit, we can, in CATIA, we can create a feature point using fast point creation, and then drag that same feature point, keeping the link with the tolerances, and then move it around on that same surface. So just for example, I am going to create a fast point right onto this feature. So there it goes, it applies right there. So if I wanted to go ahead and move this to another part on the same feature, I can drag it over here, and it's going to end up there. Keep in mind too that this is going to keep links with that same tolerance or the same MTM down the road. So once we change it, it's not going to make it a brand new one. And you can use this for DCS points and as well as feature points. And if you wanted to change like your primary locators of your move, you can do it this way. And just to show you, if I already have a point that's created on there, I can come into this feature point, go to the fast point creation. I have to do a window selection on that point, and then I can move it back if I needed to.
Jason, that vector, besides the coordinate, would update too. You dragged it to two surfaces that are going the same direction. You drag it to a different surface, right? It's going to pick up the new coordinate as well as the vector.
Correct. Yes. And on that subnote, we can also create the CATIA points, or using CATIA points within CATIA. So I'm going to go into this, the knuckle, and I just want to go ahead, and we know that we can probably create CATIA points pretty quickly. And so right now I'm in my generative shape design. So I'm going to create a point on this feature right here. I'm going to just create that 0. Okay. Go back to my 3DCS. Sorry, there's a little window there. Go to Convert DCS Point, or CATIA Point, and select this as a feature. And so what it's going to do is it's going to bring that surface in as a feature and make that point on top of that feature as well. So now it's an actual feature point. Center graph. So right here, there's our new point. We can use it to make new MTMs, new tolerances, keeping links with features, all that good jazz. I can also bring in other points from 3DCS into CATIA. So I am going to select on this fixture here that I have a bunch of points on. And I'm going to bring in the upper B1, side B1, and lower B1. And if I go up into the CATIA part now, it will have those new points in here, right here at the bottom.
That was really quick. So what did you do to bring those into CATIA from 3DCS?
So using that same dialog as bringing the CATIA point from 2DCS, 3DCS, using the same feature, convert DCS to feature point. I only had to switch the DCS to feature point to CAD point, and then select on the points that are in 3DCS. So going back down here, I can select in the tree or select in the graphics window. I just selected those and they went right over.
That's important because one of the things we promote is the pull and push from your CAD system. So when you're in CATIA, and designers have designed parts, you want to be able to pull as much as possible from what the designers have done into your model, be able to work with it, analyze it, optimize it, and then push that back into the CATIA parts.
That's right. It's all about not re-authoring data. We don't want to recreate data that's already within the CAD system. So if those points are there, we can use them. And then we want to push design locators and design features to the designer. It's not all 3DCS. We push them back at CAD points. The developers sketch around that, and they can go. There's a good integration between this tool set.
Right.
Okay, so going on to our next point, with that, creating CAD lines. So in CATIA, NX, and then multi-CAD as well, we can create lines to show, in 3DCS we can show these lines to kind of better differentiate a fixture or show our locators in a move, so when we're doing a report later on, maybe in our part 3, we can show this, advanced. It'll actually show a part when we do show only in MTMs, show only MTMs available. So that's the reporting side. But in this case, I'm going to go ahead and go into CATIA, and I am going to.
So what you're saying is you can use CAD lines to model fixtures in your model. So if you're doing an assembly, because 3DCS, one of the great things about it is it allows you to simulate manufacturing processes, not just design. So we can actually show each assembly step with the fixtures. So we can take a part, move it to a fixture, and then move that into an assembly. and show step by step, including fixtures and any variation or any processes the fixtures are involved with along the way.
Yeah.
And this is one method you can use to show those fixtures.
So I'm going to just bring this out. There's going to be a couple times I'm going to use this. So creating lines, and before I did this, I went ahead and created these 3 points, the upper B, lower B, and side B. So if I go into create a line, here's my line definition. I just have to do point to point. So I'm going to go right to 1, and side B1 is my first line.
Where was this dialog box, the wireframe dialog box?
It was in, I'm sorry, I usually just double click on a part and it goes right into it.
Oh.
But in order to do that, you can do the same thing, double click on this part, and then go to your start menu, and go to shape, and there's your GSD, or generative shape design, that modifies all wireframe. So here's the wireframe toolbar. You go right to the point, or line to line, create the upper B, side B, side B to the lower, oops, and then lower to upper. There's my triangle. There's a wireframe that I can specify or wanted to show in 3DCS. Turn this on. I'm going to change the color. I'm going to change the shape or the thickness so I can see it. To pink. Make it a 5 thickness. And then switch over to 3DCS and then update model geometry.
I think the benefit of this is just not for tooling, it's a visualization tool. I mean, you wouldn't need to have complete design on any of these parts, the upper and lower control arm. It could just be visualized, and that's what we're doing here, is providing a visual representation. We're not reinventing the wheel, we're using CATIA's functionality, but this is the benefit of an integrated tool. You have basic design features, design capability that works seamlessly with 3DCS. So once again, to increase comprehension, to give a better feel for what is going on, and whether it's tooling or a part, it really doesn't matter.
And to follow up on that, we've actually seen applications where, for example, only the points will be provided for tooling or for parts.
Sure.
And you can use CAD Lines to help you visualize what you're working with, or to help create the fixtures for a set of points, that you might have been given from the design team before the parts have even been created in CATIA.
That's exactly right. Okay, perfect.
All right, so now we got these CAD lines in here. I updated CGR. Now I just have to move this thing one more time and nominal build and deviate. We can see that the part is deviating. It actually has something to move to now. I'm going to turn my points mesh back on so we can see this just a little bit better. And it's just for displaying a fixture or displaying the moved parts better. Okay, so next we have leveraging our embedded GD&T. And this has a lot of impressive things to go about it. So first I'm going to actually show how this is created. In CATIA, they have this function called the tolerance advisor. So I'm actually going to do some creation here in the frame.
So you're going to make GD&T in CATIA.
Yep.
And then you're going to pull that GD&T over into 3DCS.
Correct.
From CATIA.
Yep. So now I'm going to switch over to my FT&A workbench. So function, tolerance, and annotation. And the dialog is called the tolerance advisor. So right now I have nothing in this frame. There's no 3D or FT&A. So I'm going to create just a plane, or I'm sorry, a datum right here on these two features. So my tolerance advice is going to show me I can create all these features. So all these features on those two planes. I just want to make a datum. From here, I can add a datum target. Or add this as a datum reference frame. And then on this side, I want to be able to add it right here. Add a profile, just a profile tolerance, making it 2. And so I got my profile. There it is. Where is it now? All right. Well, my datums are all here. So there's my datum A. My profile tolerance will show up in 3DCS. That's not. Just throw it right here. Profile. Okay. All right, going back and up to 3DCS, and I'm going to update model. I am going to update the GD&T. And I can just select the frame or select the whole part or the whole assembly. So I just got the 2. And what that's going to do is going to actually create all of the, it created the feature, it brought over the points. So, here's the frame, and here's our GD&T. I'm going to do the same thing really quick on the knuckle because I have all my GD&Ts over here. Delete that really quick. Yep. Update GD&T. Go. Oops.
So this is pulling over, you said, so if there are datum features, it's pulling that. It's got the tolerances. It's got the CAD points, all being drawn in straight from the CATIA and automatically being applied to your model.
Right.
So if your model's already been toleranced and had GD&T added to it, there's no need to add 3DCS tolerances unless you've got additional tolerances you want to add onto it, or if you're doing something like the fixtures or additional process.
Right. So from the same thing from before, we got our 4 points here. This is all from that the primary datum, the A datum, and then we also have the profile, the surface profile, and then also on the knuckle we have all these datums, which was 12. So these all brought over the same datum flatness, and then within FT&A we can, when we bring it over into 3DCS, we can modify the range. So if I this flatness wasn't, oh, let's do another one. Let's go to this position tolerance. So last position in our results was probably given a too high of output. Yeah, too high of an output. I can change the range, or if I change the range, I can also modify everything else in this dialog. And then I can update to FT&A, and that's going to push the change back to the datum or the position tolerance into my knuckle.
So basically, you can change all the tolerances in 3DCS that you pulled from the GD&T in CAD, because this works for PMI and NX as well. You can test it, so you can make multiple changes in 3DCS, test and optimize before you push back into the CAD.
Right.
So really, 3DCS becomes a test bed for optimizing your GD&T.
Yes. So now there's my 0.2. Now if I go ahead and find my nominal build. and deviate. All my tolerances are now based on that GD&T. All these tolerances in here should be turned off. And there we go. There's all my GD&T tolerances.
So he's just showing visual deviation here, where you can see the parts actually being moved and the geometry being deformed within the tolerance ranges using Monte Carlo simulation.
Okay, next point. Leveraging the joints and constraints. I see I'm going a little too fast for the computer. All right, so pretty much in most CAD systems, we do have a way of making joints or making constraints. They might be called something else in NX. But in CATIA, we have the same capability as we do have in GD&T. So we have our constraints here. We also have already created a bunch of joints or a mechanism in CATIA from the DMU kinematic workbench.
And it's important to note here that because we are working now in kinematics, you do need to have the mechanical modeler add-on module for 3DCS in order to import these joints and constraints. And the mechanical modeler is a really inexpensive add-on that gives you access to all these joints and constraints and the automatic extraction of them, as Jason's about to show, which will allow you to apply those as moves onto your model. So with the CATIA FT&A, the embedded GD&T in CAD, and with joints and constraints, you can have your moves and your tolerances drawn straight from your CAD system and automatically applied onto your model.
Okay, and just to show this really quick, I'm going to go switch over to my kinematics workbench here. I'm going to update my joints. And this process I'm going to show is only going to work if the model is actually built in CATIA, not 3DCS. So I'm going to update. It's going to build my parts based on the constraint. And then I'm going to push this automatic update for using constraints. And what this is going to do is it's going to use the constraints I already have, and it's going to create all the joints. So I can show you more. What's going to, I can either auto create everything, which means you'll also have to kind of investigate to make sure everything is right. It might just go ahead and start creating constraints, but it might not give you the right results that you're looking for.
The reason for that is because it doesn't necessarily put them in the correct order.
Correct.
And with mechanical movement and kinematic moves, because each move is tied to the previous one, the order is very important. You have to make sure that everything is assembled in the correct step process.
So you can definitely step through this process yourself. This right-hand arrow will go through each constraint or pair of constraints and add them into there as joints. So we already have these constraints made. I can go into my scenes to separate. Apply the entire scene. So if we have our constraints made, or our joints made, we can bring them in through 3DCS into DCS. I just switch back over. And just to show, we do have a bunch of moves already created, but there is no, right now, there's only that one. So I'm going to turn that off. Search constraints. And then we can specify we want joints and or constraints. And it's going to go through 9 moves created from 8 joints. And what that means, too, is that there is a command or a motion move within these joints. So my first one has got an angle-driven constraint. It's at -85 to 90, but I'm going to change that because it's going to really throw the part around. There we go. So -20. 0. Sorry, we're going to now build and then deviate. And we're going to see that the motion move is going to take that tire up and down based on a spring, based on the motion or the joints that we applied, plus hole pin floats, and tolerance deviation.
What's nice about the joints and constraints and using the kinematic moves is, as you can see, it allows us to simulate in multiple positions. So rather than just in a single assembly position, then having to change the model itself in order to be in a different position, we can move it through a full range of motion. And once you're doing your analysis at the end, you can actually analyze it at every position.
Okay, so that is covering basically the joints and constraints and the GD&T. So now we're going to go back to our modeling process a little bit. The measurement generator, which is a dialog that pretty much takes all the data we just created, the points, mesh, and it makes it into, we can make it into an XYZ or using the associated vector of our points.
Making measurements based on that, you mean?
Yes. So I'm going to go either into the DCS drop-down here, into the MTMs and measure generator. So in this dialog, we have our option to create point-to-point or nominal point measurements, either in the XYZ and associated vector. Down here, we can select a part, and basically it's going to bring in any points that we have on, say, I just picked on the knuckle. So here's my big list of points. Down here is the last 2 points I created. Also, I can add an upper or lower spec limits. I can change the spec mode to absolute or relative, add a prefix to the name, or add a description. But I'm just going to hit the add button. So now it's going to create these 3 points, or 2 points, into 4 different measurements and add them to the model. So here's my new measurements. Now if I go ahead and now I'm going to build. And right now I only have GD&T turned on for my knuckle. I'm going to just run a really quick simulation at 100. So we got any questions going on while this?
Yeah, you know, there is one here that I do want to bring up that, you know, it'd be great if we can talk about real fast right now.
Yeah.
A little more related to mechanical. Can we use this type of model to create tire sweep boundaries?
I mean, it definitely is providing the overall variation at that range, but sometimes based on what that question means, sometimes people are looking for a 3D volume of geometry, like you want to see the upper lower control arm, and you see this 3D graphics of that, or making this like almost like this overall solid that would show you this overall volume. We don't do that, but we certainly can provide the points at the extremes of that, and we can know, you know, from a variation-wise where they are at each of those given levels. We'd probably have to talk to this user a little bit more to get a better idea of what that tire sweep, you know, output would be. But if it's like a 3D CAD, we don't do that. But we can at least give variation at any given level of that variation.
All right, so all right, going on to my next point. That was the measurement generator. Now we just want to basically copy our known measurements or known tolerances that we have. And there's like a few different ways to do that. We have a copy data, copy and paste, and then quick copy. So using our knuckle again, I can go into, I'm going to turn these tolerances back on. I'm going to start with quick copy. And it should be right here. So here I'm going to select on my knuckle, and I'm going to apply it to the frame. Switch tolerance. So right now we have these 4 tolerances that I would like to bring over to the frame. So if I hit copy, it's just going to copy those same tolerances over. So now if I go up into the frame, it's going to have those new tolerances, and I can edit them. I would have to edit them. So I would have to edit them. They brought over, they're still linked to the CAD services on this knuckle. So I'd have to delete these and add the features based on the frame. But what this will do is also copy the type-in direction if I don't want to lose that. It will copy over the range. It will copy over the description, anything that I don't really need to change that I already have specified in another tolerance or another move. I can copy those over using copy data.
So what would be a good application of that?
Well, so you have a fixture that's commonly used from one station to another. You got an underbody that's going. So you would want to duplicate these same tolerances from one fixture to another that are identical. You know, I know we're not planning on talking about that today, but when it's a total duplication, we can also use the mirror command, which will mirror all the moves, all the tolerance measurements as well. The copy data is commonly used when you have similar parts, not like totally separate parts. Similar parts that are used, like a fixture. Or maybe a user makes a mistake and they don't want to copy, they put the tolerance in the wrong location. They want to just move it over. So it's not always a copy data. Sometimes it's a move, tolerance, or measure as well. We typically use copy data for the points when we're moving the object to the target point. Create a point on our object, we use copy data to copy them over to the target. But then the tolerance, everyone's going to be a little bit different. You might have a move that gets used commonly over and over, so then you'll copy that move over.
Yeah.
Or you might decide, I'm going to change my process. I want to actually move a DCS move from one level to another because you're doing a what if. So there's a lot of different scenarios of using copy data. Another kind of fast, ease of use functionality, so you don't have to do everything one by one. You can speed up your modeling process.
Great. So you want to go back to your agenda?
Well, one of the other things that I was going to show is quick copy. Quick copy. If I right-click on here, go to quick copy, it will just quickly make a copy of that same tolerance within the same part. It's going to keep the same CAD features. So if you're going from like a linear tolerance to, or a feature tolerance is a better example. Feature tolerance, I can quick copy and then go into that tolerance and change it, whether it's a profile or a position tolerance. I can keep the range the same, I can keep the points the same, and then basically I've already got 2 or 3 tolerances made.
So it's a nice, just faster modeling technique.
Yeah.
Especially if I've got multiple tolerances on the same part.
And then for most users, they already know what copy paste are. If we just select on a couple of these, we can just use copy and then paste it into, say, another part. It's pretty much very similar to copy data, or it's just copy and paste without using the dialog. But that is it.
All right. So we're 37 minutes past the hour. So we've got about 10 to 15 minutes available for some Q&A. If you have any questions or you'd like to see something in a little bit more detail, please use your interface on the right to submit that question. We'd be more than happy to show particular applications, or if you want to see something done in a different method, just let us know. We'd be happy to showcase it. While we're on this, if I wanted, could you show real quick, based on the copy, how I could use that to quickly create a fixture? Because I can copy points from CAD to create a fixture and use CAD lines?
Yeah.
So within the model itself, so really what's being asked here is if I'm giving CAD parts from a designer, can you just talk real fast about how I would use those to create a fixture?
Oh, sure. Yeah. So for a fixture is usually something that we reference, or a 3DCS will use to reference an actual manufacturing fixture. So we can take the actual CATIA data. Say, for example, we already have these 3 balls in here, these spheres. We have CATIA points on them, and that would actually can be used in a fixture. So if I'm going into, let's see, find the knuckle. So I got the lower B, upper B1.
You don't necessarily have to build it, but if you could just speak to it.
No.
Yeah.
So I can take these points, bring them into the knuckle, which what they are going to do is bring them right into the knuckle part in 3DCS, create another copy of the part, or an empty part. So I can just insert component, insert a new component, or new part, and I can copy those new points right into that part, and that would be based on this XYZ position of that the knuckle, and then basically from that that fixture, I can just translate it out like I did with the steering knuckle fixture here, and there's my fixture, and then with all the same 3 points.
Great. Okay, so next question. This one's pretty important. Can you show again real quick how to create the multiple measurements from the measure generator?
Yeah. All right, so back into underneath this copy data, we have the measure generator. So here we can.
Is there an option for measure generator from the drop down on the top?
Or a DCS?
Yeah, 3DCS.
Yeah. So up here we can go to the MTN GD&T, and at this second, or this 4th one down, 5th one down, is the measure generator.
Great. Thank you.
So if I can turn on all these XYZ directions, I can turn on diameter if exists. What that does is going to create a diameter measurement. It's just going to measure the diameter of a circle size. And then associated vector will take the actual vector of the point that we are selecting when we create our measurement. So we might get an XYZ, but the vector of the point might be 0.99 in the Z direction, or it might be slightly skewed or off of the main direction. So if I go ahead and select a part, or if I can select features individually, I can start picking on points that I already have. 1, 2, 3. So I just picked the upper B of the steering knuckle. And then what it's going to do is going to create in this assembly, the final assemblies, which is the top root, or I can change it into a subpart or a subassembly. I want to keep it right there, so I'm going to add these. I have to make sure they're all selected. Add, and then apply. So now once I go down here, here's all my new measurements based on an XYZ. You can see the directions here. The XYZ directions and an associated vector direction.
One of the common uses of measure generator is to put measurements in the XYZ direction on all your piece part points, and you run your analysis up front to actually see, do each of your features have the right tolerances that go in the right direction. The other purpose is to put those measurements at the assembly level to check the XYZ of those measurements that might be measured in a CMM or some sort of measurement device that we're trying to analyze. And I mean, if you can imagine creating all those individually. That's going to take a lot of time to do each one of those individually. Plus, you have the potential mistake of maybe not updating the vector. Here we're doing that all in one click and kind of just mass producing these. So validation, creating CMM types of measurements, tracking a point through a range of series of stages. You want to track a point and find out what stage it actually goes up at. Measure generator is an excellent tool to save time in modeling.
So what about point-to-point between two parts?
Sure. Same thing in that same measure generator. I can switch to point-to-point. Something that I found out yesterday, we can't select a part in order to do it because we can't select 2 points at once. But we can do select feature, and then from here we can just start selecting points that we know of. So now this is going to that part to the fixture, so this is not, but I can take this point and then this point, that's one pair.
Right. So now pick that point and close out of there, Jason. So that's going to show up as one feature in our feature list.
Yeah.
Now for that one feature, you can go ahead and create XYZ measurements between those.
Yes.
So it's going to really track between those 2 points.
Right.
So let's just say you have a couple holes that you're trying to determine the variation between these 2 holes that are on an axis. You might want to do a measure generator since it's a square grid hole to really figure out where that hole is going. Once again, you can create all 3 measurements. This is not a new capability inside DCS. It's just a faster way of doing something that you could create 3 point-to-point measurements. This is just a faster way of doing it.
Yeah.
And increasing your accuracy too, because you don't have to worry about updating the vector and making sure you switch everything correctly.
Right.
I don't know if you touched base on it too, but each time you create a measurement, you can specify the spec limits, which might be different, right?
Yep.
And then the other thing you can do is specify, if you want a prefix or a suffix on that measurement name to give it something a little bit unique, right?
Yeah.
We're just thinking of another kind of use case. Sometimes when we build 3DCS moves, we want to make sure that there's no variation between the object and target points. So measure generator is another way of quickly making those 6 points between your object and target features, maybe along the vector direction, maybe along some type-in direction, to quickly create those validation measurements for your model to make sure your results are right or your move was built properly.
Right. So there's the point-to-point measurements that I just created. It is using upper B to the fixture. And what Dave was saying, we can change, when we bring that spec limit, these will be specified to that spec limit I changed in the dialog.
All right, good. Oh, sorry, one moment. So can you bring up the list real quick, Jason? Let's just recap real fast to make sure everything's been cleared while I go through some of these real fast.
As I look at this list, I'm trying to just categorize, and I think the point is that we don't want users to have to re-author data. We don't want them to have to define data in our tool that's already been defined somewhere else. We want to reuse that data. That improves speed, accuracy. We don't have to worry about inconsistency between the CAD and the DCS model now. When you use GD&T, the GD&T is properly defined within the GD&T module. We're making sure we get that right over. There's no transposition errors. You think about just leveraging functionality that's already there, like just drawing lines of basic CAD functions. That's the benefit of an integrated solution like 3DCS, is that we take advantage of that. Or quick things like just, hey, you're trying to figure out where your primary plane should be, so you don't want to recreate points, you just want to reposition them. You want to simply drag them across the line. Same thing with those joints and constraints. If those things are there,
yep,
why not reuse those? Why not pull those into DCS so you don't have to create the DCS moves.
And CATIA does offer that sometimes too, where you're already creating dimensions, or you're already creating something that's already available, like in a sketch of CATIA. You might already have a gap distance of that sketch. All you need to do is just bring it through CATIA and then bring it into 3DCS. Same thing I showed with joints and constraints.
Right. And you know, I know a lot of these functions like measure generator and copy data have been in the software for a long time, but I'm hoping some things we've done today is just kind of give some more application of why we would want to copy or why we would want to move the given DCS data types around, and it's all about speed. It's about performance, and it's about accuracy. Measure generator is about accuracy and validation, and quickly making efficient models accurately, and that's what we're trying to do with 3DCS software across the board. We're showing CATIA, but these functionalities are consistent, and that's our goal as we develop integrations and we develop our multi-CAD solution to have as much consistency in the look and the feel in all the tool sets. So.
All right, thank you, Dave. So we're now 15 minutes past the hour. I don't want to keep everyone all day here. So at this time, I'm going to take a couple of these remaining questions offline, and we're going to just stay on the line for another 10 minutes in case another question does come up. So if there's something particular you want to see that's a little bit more unique to your situation or specific to your issue, we have a few minutes. We'd be happy to help. But otherwise, at this time, I'm going to be stopping the recording, and I'll be closing down the webinar shortly. I want to thank everybody for joining us today, and remind you once again, we do have the third part of our 3DCS Essentials coming up the 1st of December. We'll be showcasing things like Excel, export, import, some measurement plan automation, and some great reporting tools. So make sure you sign up for that or fill out the survey to be auto-registered. Thank you again for joining us today. I really appreciate it. I hope to see you next time.